I want us to look at the 4 quadrants, and let's talk about all of the 6 trig functions and their signs in each quadrant. In quadrant 1, all functions, all the trig functions are positive. In quadrant 2, only sine and cosecant, which is its reciprocal, are positive. In the 3rd quadrant, only tangent and its reciprocal cotangent are positive. And in quadrant 4, cosine and its reciprocal secant are positive. So this is very helpful to you when we start talking about all 6 trig functions in all the different quadrants. Now, here's a little saying that you might use to remember what we just gone over. A smart trig class, that's what ASTC stands for. A actually means that all trig functions are positive in quadrant 1. S stands for sine and its reciprocal cosecant are positive in quadrant 2. They're the only ones. T, tangent, and its reciprocal cotangent are positive in quadrant 3. And then C stands for cosine and its reciprocal secant are the only positive ones in quadrant 4. Now, I've drawn something for us to look at and use and talk about. Here we have the x-axis. Here we have the y-axis. We have 0 degrees. We have 90 degrees, which is pi over 2. We have 180 degrees, which is pi. And then we have 270, which is 3 pi over 2. So I want to talk about the value of the x, the value of the y, and the value of the r in all 4 of these quadrants. Looking at quadrant 1, just quadrant 1, okay? Your x is positive. Think about it. X-axis, we're on the positive side. Your y value is also positive. Now, let me tell you, your r is always positive in all 4 quadrants. The hypotenuse of these right triangles are always positive, okay? So that's quadrant 1. In quadrant 2, the x is negative. The y is positive. These values are positive. And of course, your r is always positive. In quadrant 3, your x is negative. Your y is negative. You're going down. The y values are negative. And again, your r, which is your hypotenuse, is positive. You see the 2 y's are negative down here in 3 and 4. Now, in quadrant 4, x is positive, y is negative, and again, that r is positive. So when you're drawing these angles in these different quadrants, now you know about the x and y signs, and that r is always positive in all 4 quadrants. So, with that being said, let's look at this example. You are given that tangent of theta is negative 2/3, and cosine of theta is greater than 0. Let's find cosine and cosecant. So, I'm going to draw this. Now let's think a minute. We're given tangent of theta. Think about it. How do we find tangent of theta? Well, tangent of theta is y over x. So my y is negative 2 and my x is 3. Now think about it. Y is negative 2, x is 3. So if y is negative 2, I'm down here. If x is 3, that's positive 3, 1, 2, 3. So if x is 3 and y is negative 2, here's my point, okay? So I'm in quadrant 4, so I'll draw this angle back up to the x-axis was here. This is theta. All right, so your y was negative 2, okay? Your x is negative 3, positive 3 is your x. Now what is r? Well, to find r, we will need to use the Pythagorean theorem. Now also we were told that cosine is greater than 0. That's positive, okay? Is cosine positive in quadrant 4? Yes, it is. Think about it. Cosine is x over r. Well, x is positive and r is always positive. So I'm in the right quadrant. I am in quadrant 4. Now let's find the value of r. So I have x squared plus y squared equals to r squared. We know that r is equal to, when you take the square root of both sides, r is equal to the square root of x squared plus y squared. So to find r, I have x, which is 3 squared, plus y, which was negative 2 squared. So that gives me 3 squared gives you 9, negative 2 squared gives you 4. Therefore, r is equal to the square root of 13. So here I have r equaling to the square root of 13. Okay? So we know we were given tangent. We derived that we were in the 4th quadrant. Now we have been asked to find cosine of theta and cosecant of theta. Now cosine of theta, recall, is x over r. Cosine would be x over r, adjacent over hypotenuse. So my x is 3 and my r is the square root of 13. Now you can't leave me a radical in the denominator, so rationalize that denominator by multiplying both numerator and denominator by the square root of 13. So you get 3 times the square root of 13 over 13. Square root of 13 times square root of 13 gives you 13 without a radical. So there's your answer for cosine of theta. So ends up your cosine of theta would be 3 square root of 13 over 13. Now, cosecant. Remember, cosecant is the reciprocal of sine. Sine is always y over r, so cosecant is r over y. Okay, r over y. So r is the square root of 13, and y is negative 2. So it's okay to leave a radical in the numerator. You just can't leave me a radical in the denominator. So we have solved this problem. Cosine is 3 times the square root of 13 over 13. Cosecant is the square root of 13 over negative 2.